If you think about it, many things in our lives are rhythmic. Rhythmic oscillations and rhythmic movement goes way back in evolution. A jellyfish swimming in the water is actually very elegant and can execute this beautiful rhythmic movement, and it has very few neurons. Rhythms are just everywhere in biological systems.
From the offices of the Weill Cornell Medicine Brain and Spine Center in New York City, this is Your Brain with Dr. Phil Steig. Internationally renowned scientist and researcher, Dr. Phil Steig is neurosurgeon-in-chief of the New York Presbyterian Weill Cornell Medical Center. This week, Dr. Steig and his guest explore rhythm in the LIVELab.
Hello, and welcome to Dr. Laurel Trainor, Professor of Psychology, Neuroscience, and Behavior at McMaster University. She is a world authority on the importance of auditory development, particularly in the perception of music. She is also the director of the LIVELab, an acronym that stands for Large Interactive Virtual Environment, a unique combination of a concert hall environment and neuroscience research facility. Laurel, thank you for being with us today.
Oh, my pleasure.
So, Laurel, why don't you share with us what you're focusing on in your research and specifically how the LIVELab makes that possible?
Well, I'm interested in virtually all aspects of music, so my research actually covers quite a few areas. But the LIVELab in the Institute for Music and Mind is a very special place. It's really a unique facility. It's a fully functioning concert hall, about 100 seats, 106 seats. But in addition to that, we have all kinds of equipment in there so that we can do scientific studies. So, for example, we have motion captures, so we can measure how audience members move when they listen to different kinds of music. We can measure how they interact with each other. We can measure how performers move to communicate non-verbally. We also can measure brain responses. So we have EEG in there, where we can measure the brains of musicians as they interact, audience members as they participate, and we can measure other physiology, heart rate, so on. So it's really a pretty unique space.
I was most interested in reading about your work when you videoed and recorded the performers themselves, the musicians, and the effect of body language that it had on their performance and on each other. Can you describe that?
Yeah, well, if you think about playing with other musicians, it's a pretty complicated task. I mean, it's hard enough to play your instrument. So if you think about what do you have to do to play your own instrument, well, your brain has to be constantly predicting what it wants to play next, because it takes a certain amount of time to plan the motor movements and execute the motor movements to put your fingers down, for example, at the right time. So your brain is continually sort of predicting the future and planning for the future. But when you play with other musicians, you have to also predict what they're going to do next, because if you wait to hear them slow down, speed up a bit, or, play suddenly loud or whatever, if you wait for that, you're too late. You won't be with them. So your brain has to be predicting ahead of time what they're going to do in addition to planning what you're going to do. So that's pretty complicated. So we can get at those processes in a few different ways, and one of them is through motion capture. So this body language, as we say. In a number of studies now, we've looked at the body sway that musicians do when they're playing. So obviously they have to move to play their instrument, but in addition to that, musicians constantly sort of sway their body. Why are they doing that? And it turns out it's largely unconscious.
Really?
We think that it actually is reflecting their thought processes for planning what they're going to do next. So it's a little bit like when we talk, we move our hands. And we're usually unaware of moving our hands, but we do it. And if we don't move our hands, it actually, if we prevent people from moving their hands, it impedes their ability to form sentences. Their speech is not as fluent. So this is what we call embodied cognition, that our thought processes are deeply connected to our bodies, and we feel our thoughts in a way through our bodies. So they reflect what we're thinking. So with our musicians, we measured the body sway of each musician, and then we analyzed how does the movement of one musician affect the movement of another musician. So there's sort of two main things that we can look at. One is how synchronous are they? So are they moving at the same time? But the other one is how predictive are their movements? So can I take the movement of one musician over a short period of time and then predict how another musician is going to move next? So if I can do that, that's not simultaneous, but that's showing prediction or information flow, or we like to think of that as communication. And so what we found, in fact, in these string quartets, the more of this prediction, the more of this communication, the better their performances were rated.
So both the audience and the performers feel that it's better when the sway, as you call it, is more synchronous.
Well, not necessarily synchronous, but more predictive. So when there's more communication from one body sway to the other, yeah.
And that also varied, as I understand it, depending upon who the leader was. Did you ever do it where nobody was the assigned leader? And what happened with sway there and the performance?
Yeah, that's a really great question. Yeah, so in some of our experiments, we wanted to see, can we manipulate who's communicating with who, like who is following who? So we just assigned different people to be the leader on different trials. And in fact, it does change the whole dynamic of how they're communicating. And then we thought we'd be really clever and do what you suggested, which is, unbeknownst to them, assign nobody as leader. Mm-hmm. And in other trials, we assigned everybody as leader. And the interesting
Start
thing...
competing with each other.
The interesting was they knew immediately. They only played a few notes, and they said, hey, something's really off here. Like, this is weird. Like, they knew immediately. So again, it just says how important those communications are between the musicians.
I think all of us know the answer to this, particularly those of us that went to Broadway when the musicians went on strike and they played recorded music. But as I understand it, there's a difference in the effect and behavior when hearing live concerts versus a recorded concert. What is that?
Yeah, so we've done a number of studies now where we've tried to manipulate different things in the performance hall and see the effect that they have. And so one is this idea of, does it matter if it's live? Because maybe you just like to go to concerts because you like experiencing them with other people, and I think that is part of it. But we manipulated this by having a show, a rock concert in fact, where some people experienced it live, then we did a recording of it, and with the sound system in the LIVELab we can reproduce the sound exactly as it occurred during the live performance, and then had a video of the show. And so another group of people experienced that. So they experienced it in this social setting of being at a concert. It was a new album release, so people were excited about it. They hadn't heard music from this band for a while. And what we found was, in fact, we measured different things, but the main one was how the audience moved. And when there was a live band there, they moved with more vigor. They moved with more energy than they did when the live band was not there. And they rated as having a better experience.
Personally, I would have to totally agree.
Let's take a moment to appreciate what the concert experience might be like from inside a performer's head. We'll visit with one of the participants in the LIVELab studies.
My name is Adrian Fung. I'm the founding cellist of the Afiara Quartet. Working with Dr. Trainor was terrific. I really enjoyed being able to see like our alpha waves and to see certain aspects of our energy, how we moved. And to really be able to see how good we were as communicators. Here in this setting, we got to discover, we got to explore whether the things that we did all the time on the world stages really worked. And I remember really trying to play tense and eerie. And then to realize that some people were switching on their survey switches calm and relaxing just because it was soft and slow. And then we realized something, like we're not as good as we think we are. We had already won the international awards and certain prizes, and we were very humbled to win those things, but we were more humbled to realize that what we were trying to communicate was not necessarily what was actually being received by the audience. The other aspect of it was learning from each other. When she turned us with our backs to each other, and this is an experiment that I thought was terrific, where we're trying to learn how to be led or to lead when you don't have the visual cues. She went through several different experiments where one of us was the appointed leader on this checklist. We're like, okay, this is number 3, so okay, I'm not the leader this time. Number 4, I'm going to be the leader. And we're playing through these different pieces. What really tripped us up was when we played a series of them where nobody was the leader. I was so frustrated at the end. I started thinking that maybe someone wasn't being clear, or maybe I wasn't being sensitive enough. After the experiment was done, I was talking to my colleagues, and they're like, well, no, we all knew that there was no leader. And I'll tell you, the last person to realize that there was no one was me. I did find that this was an incredible learning experience.
Our thanks to composer Dina Gujaratna and the Afiara Quartet for sharing their music and their brains with us.
In most of your writings, you assert the fact that music is important in our development. More specifically, how are rhythm and interpersonal synchrony important in our social development?
Yeah. We tend to think of music as having 2 main elements. One is pitch and one is rhythm. And rhythm is probably the more fundamental one. If you think about it, many things in our lives are rhythmic. From sleep-wake cycles are rhythmic, our heartbeats are rhythmic, we move rhythmically. Rhythmic oscillations and rhythmic movement goes way back in evolution. So a jellyfish, for example, may not look so nice on the shore, but a jellyfish swimming in the water is actually very elegant and can execute this beautiful rhythmic movement, and it has very few neurons. Rhythms are just everywhere in biological systems. So why is music so powerful? Why does music affect us so much? Why, when something happens in the brain and rhythms are not processed well, why does that have devastating effects? It really goes back to this idea that our whole brain is organized rhythmically, and music makes use of that. So music is a very powerful stimulus for engaging rhythmic movement, for engaging rhythms in the brain. So when you listen to a rhythm, we can take EEG and measure what your brain is doing to respond to that rhythm. Mm-hmm. And what we see is that the brain actually responds, it entrains to the rhythm. We can measure in the brain responses the same tempo or frequency of the rhythm that the person's listening to.
So when you record from 2 different people at the same time, I imagine you're then suggesting that if there is synchrony between the 2 brain rhythms, that enhances social bonding and, as I understand it, also altruistic behavior?
Yeah, so we don't know the exact mechanisms now, but what we do know is behaviorally, if we have 2 people, say, experience the same rhythm, and particularly if they move together in synchrony to that rhythm, because rhythms make us want to move, then afterwards they feel more affiliated. They'll rate each other as liking each other more than if they moved out of synchrony with each other. They'll trust each other more, and in fact, if you give them a game like Prisoner's Dilemma, where they can choose to cooperate or choose to compete, they'll cooperate more. So experiencing music, and particularly the rhythmic aspect of music, experiencing that with other people has really profound social implications. It bonds us together. And this is probably why we have music at parties, we have music at weddings, we have music at funerals, at religious services. Basically, anywhere where a group of people wants to come together and feel a common bond, we have music.
Reading through your articles, I just learned all these things that I'm completely naive about. And this other thing called speed dating. So, all right, I'm really curious. Number one, what is speed dating? I'm showing my age, but also the effect of body sway on speed dating and romantic relationships. How does sway affect it?
Well, speed dating may be a thing of the past because of the pandemic. And we actually did this study just before the pandemic. But the idea of speed dating is, if you don't want to waste a whole lot of time going on full dates with people, you could go to a speed dating event where, in our case, we had 30 men and 30 women. And you could meet with each one for a short date of about 3 minutes. So each couple would meet at one table, and then the women stayed where they were in our case, and the men would rotate around the tables. So at the end of the night, you would have been exposed to a number of people, and you could choose if you wanted to then go on a real date with any of those people.
And it was affected by music, however, right? If you played particular kinds of music, it enhanced the sway?
That's right. So, well, we measured body sway. So these back and forth movements that we just unconsciously do when we're communicating with other people. Mm-hmm. And by analyzing how the two people were interacting through their body sway, and in particular whether we could tell from the way one person's body sway was happening, how the other person was going to move next. The more of that there was, the more likely they were to want to see each other again at the end of the evening. But the other interesting thing was music itself affected whether they wanted to see their partner again. And the music that was most effective is what we call high groove music. So music that is groovy, the definition of it is that it makes you want to move to the music. Mm-hmm. So if you think about Stevie Wonder's Superstition, for example, that's highly groovy. Most people can't sit still when they hear that. And we're starting to know some of the things that make music groovy. So there's an optimal amount of syncopation, so an optimal amount of notes that aren't on the beat. And that
heavier bass? Is heavier bass, does it make
heavier
it
bass? Yeah, definitely. Yeah. So in any case, in our speed dating, half the time we played groovier music and half the time we played less groovy music. And people were more likely to want to see each other again if they experienced each other while listening to groovy music. Interestingly, how synchronous their movements were didn't really affect whether they wanted to see each other again or not. Mm-hmm. What mattered was whether the partner reacted to how the other person moved. So if one person moved a certain way and then the partner reacted, and it didn't even have to be the same movement, it just had to be predictable. So that's this communication. If you feel like what you're doing is affecting the reaction in your partner, then you have a more positive experience and you want to see that person again.
I was just looking for some guidance so when I watch my children with partners, I can maybe be a little bit predictive on where it's going. I'm curious about your studies on 14-month-old children. What constitutes rhythm in a 14-month-old child?
Well, our studies actually going back even earlier than that. Now we know in premature infants that their brains are already encoding rhythms. We're doing studies on mother-infant interactions. Those are rhythmically based, and parents put extra rhythms into the speech to infants and all this kind of stuff. Our studies of 14-month-old infants, so these now, think about it, are fairly sophisticated processors of auditory rhythms and music. But what they can't do very well yet at 14 months is move their own body in synchrony to a rhythm. They're still kind of immature in how they can control their movements. So it's hard for them to actually synchronize themselves to a rhythm. But they've had lots of experience synchronizing to rhythms because their mother will hold them and walk to them and sing to them and rock them and so on and so forth. So what we did in our study is we took 14-month-old infants and we thought, okay, they can't synchronize very well themselves to the rhythm, so we will bounce them. Mm-hmm. So we bounced them in time to the rhythm of a musical piece, And at the same time, an experimenter faced the infant, and she either bounced in synchrony with the infant, or she bounced at the wrong tempo so that they were out of sync. And then immediately afterwards, we looked at how helpful the infant would be. So at 14 months, infants will actually do overt helping behaviors, which is why we chose that age. So for example, the experimenter would be pinning clothes on a clothesline and she'd accidentally drop her clothespin. And then we gave the infant 30 seconds to either pick up the clothespin and hand it back to her, or not. So half of the infants who bounced out of sync and half of them bounced in sync with that experimenter, they're about twice as likely to help if they just experienced less than 4 minutes of bouncing in sync with that experimenter who was a stranger previously. Yeah. So that's pretty powerful, that just a few minutes of moving in sync at that age makes infants want to be affiliated, want to help.
Yeah, it's fascinating. Explain to me, this is a term that I had never heard of, developmental coordination disorder. What is it and how common is that?
Yeah, it's actually quite common. It's estimated between 6 and 10% of children. And basically, it's the kids who are clumsy. So they have trouble catching a ball, they have trouble running, trouble tying their shoes. So it can be gross motor, it can be fine motor, but they have motor deficits. So that's how it's always been defined. Yeah.
And it's related to poor rhythm perception? Or is it that plus?
Yes, it's been defined as a motor disorder, and it's been defined as having timing and rhythm deficits in the motor system. So repetitive movements like walking or running are difficult. It's always sort of been known to have a motor component, but what we were interested in, because our studies of the brain show that when you just listen to an auditory rhythm, it activates auditory areas of the brain, not surprisingly, but it also activates premotor areas of the brain that have to do with motor control and motor timing. Mm-hmm. And so now we actually think that the way the auditory system perceives time involves the motor system. It's a loop between auditory and motor areas, and that's why music makes you want to move to it, because when you hear the music, it's activating motor areas. Yeah. So we thought, well, if the motor areas are not doing rhythm very well, that should affect their ability to hear auditory rhythms, if our model is correct. And that's exactly what we found. So these children, if you just have them do rhythm perception, they're not as good at perceiving rhythms as typically developing children.
I mean, I don't want all the mothers listening to this, if their 14-month-old child doesn't have any rhythm, to think that their kid has developmental coordination disorder.
No, not at all. It takes a long time for motor coordination to develop. Yeah.
Yeah. How might auditory rhythm training be used to treat other disorders? You link the inability to understand rhythm with dyslexia and ADHD. So in reverse, how can we treat it with rhythm training?
So there's probably the most research been done on dyslexia. So dyslexia is defined as a problem reading, but in fact, most dyslexias go back to a problem in perception, and rhythm perception in particular. What's really interesting is that if you give an auditory rhythm to a child before you give them some speech to process, it actually helps them process that speech. So it's as if it says to the brain, okay, you have to be in a rhythmic mode here, and now you can process the speech better.
So it's not a visual problem, dyslexia?
Most dyslexias are not visual problems, they're actually auditory problems.
Really? That's fascinating. Okay. Do you have examples of how mothers use music differently to kindle or imprint or entertain their child?
Yes, so one of the interesting things is that mothers sing to their infants every day. So we've done diary studies, and they're singing all the time. They're singing when their child takes a bath, they're singing in the car, they're singing them to sleep. And they're singing in different styles at different times to achieve different caretaking goals. So sometimes they need to calm the baby down and try to put the baby to sleep. Other times the baby is alert and they want to show the baby sort of interesting things in the environment. and they sing in very different styles.
Same song, but in a different style.
So, yeah, in one experiment, we had them sing the same song, first as a lullaby or a play song, and then the opposite after that. So here's a mother who's singing a lullaby to her infant.
Ooh, ee, ooh, ah, ah, ting, tang, walla, walla, bing, bang. Ooh, ee, ooh, ah, ah, ting, tang, walla, walla, bing, bang, woo, woo.
And here's the same mother singing the same song, but in this condition, she's singing it as a play song.
Ooh, ee, ooh, ah, ah, ting, tang, walla, walla, bing, bang. Ooh, ee, ooh, ah, ah, ting, tang, walla, walla, bing, bang, boop, boop. Ooh, ee, ooh, ah, ah.
So you can hear it's like night and day.
Walla,
So
walla,
mothers
bing,
are
bang.
adjusting the way that they're singing continually, depending on the infant's reactions. And so there's this constant dance between the mother and the infant, this interaction between mothers and infants. And we're just starting to explore the role that music is playing in those very complex but really important interactions.
The question I was thinking about was the response of the child to the different singing different?
Yes, so we did some studies, a decade or so ago where we didn't have the technology we have now. When infants listen to play songs, they tend to look around the world. But when they listen to lullabies, they tend to look down. One of the places we want to go in the future is to better understand how mothers and fathers and caregivers in general use music in their early interactions with infants. We think that it's really important, but we don't know a lot about how it affects the infant and that dynamic of how they're communicating with each other.
That'll be great work and very important work. Any help we can get in child rearing is going to be a positive thing in America. When I was a young kid, we had music class 3 times a week, and now we're seeing all these financial cuts in music education. What are your feelings on that?
Yeah, I really think we're doing this at our peril. Music education has been, in the Western tradition anyway, for probably a couple thousand years at least. And we know that music is good for our emotional well-being. We know it gives us a way to express ourselves when we can't do it non-verbally. We know that music making with other people bonds us with those people. It's no mistake that in the kindergarten classroom, teachers sing songs all the time. So denying people a music education, I don't think is the way to go if you want to create a better society.
Dr. Laurel Trainor, a world's expert on the importance of music in our lives. Thank you for highlighting how important music is in our social development and in our altruistic behavior patterns and helpfulness, also in our appreciation of each other and romantic relationships. Thank you so much for being with us.
Oh, my pleasure.
This is Your Brain with Dr. Phil Steig is produced for the Weill Cornell Brain and Spine Center by the Really Interesting Picture Company. Episode producers are Geraldine Abinader and Hildy Rubin. The series is directed and edited by Tom Veltri with music by Lenny Williams. The announcer is Allison Power. Please sign up for our newsletter and get access to special episode-related bonus content at thisisyourbrain.com and follow us on Facebook at This Is Your Brain.